Hello, everyone, and thank you for joining us today. My name is Michael Weir. I'm a senior technical enablement engineer in the Ingram Micro Cybersecurity Center of Excellence, here to talk to you today about the OWASP Top 10 for large language model applications in 2025. Quick agenda of what we're going to talk about today. If you've seen me present before, you know I like to talk about history, so we're going to talk about the history of the large language model, modern history of it today first. Then we're going to go to the OWASP Top 10 itself. We're going to talk about how to defend against some of those top 10 in your application, and of course, we're going to talk about the conclusions. So looking at the history of large language models, the idea of having automatons that could generate something to interact with humans goes all the way back into the thousands. But what we want to talk about here and what I want to talk about is the modern applications of it, and times we've done it in something we would recognize as interacting with a computer or a machine. To start that out, we need to look back at about 1964 at MIT. Researchers created this thing called ELIZA. ELIZA was the first natural language processing program, basically a chatbot, and to simulate conversation with users using pattern mapping. We would consider it to be very simple today, but at the time it was revolutionary and shocking to those who were using it. Next, in 1988, IBM made a large language model-ish thing called a statistical machine translation engine. What this was is it produced text based on statistical models instead of the previous versions of using rule or example-based models to make text. This meant that it was more diverse. It was something we would think more of as like generative, more versatile, that sort of thing. Researchers in 1997 in various locations working together came up with this thing called LSTM, long short-term memory. This was the idea that when we got an answer out of our statistical machine translation or whatever other method we were using, it did multiple passes at the same data through these neural networks. So you got a greater variety of answers that could be weighed together and thereby ended up more accurate in the end. Do a little jump ahead in history there. We're going to come up to 2011. We had Google Brain. Google Brain was a deep learning AI. If you're familiar with TensorFlow, then you're familiar with Google Brain. Won't say any more on that because I think a lot of you people listening will be. Then in 2018, we get to the GPTs. Now, GPTs are not chatbots. GPT stands for Generative Pre-trained Transformer. It's just a model. Now, the original models, GPT-1 and 2, OpenAI thought they were too powerful and did not want to release them to the public. But then 2022, as we're getting into GPT-3 and beyond, they make something called ChatGPT, which is it's a chatbot that leverages the generative pre-trained transformer, the GPT part of ChatGPT. That's when that burst onto the scene. And of course, generative AI has been super hot since then. And then in 2023, in response to that, OWASP said we need to put together some kind of security framework for this. So we are going to put together the LLM application top 10. Talking about the actual top 10, there's a couple of things we do need to know first. So first thing we need to note is since this is an OWASP standard, the OWASP standard is about CAI. It's about confidentiality, availability, and integrity of information, or some people might call it CIA. I just want to confuse it with the organization. And it's about the large language models and how it's being applied. So it's not just the model itself, it's how you're applying it to your specific application. With that in mind, here are the top 10 vulnerabilities. Oh, I should also say that none of these are mutually exclusive with any others. They're all interwound, they're all chained together. Whenever we talk about one, we're probably talking about leveraging some of the others to get there to that point as well. Either way, first, the one that we're probably all most familiar with from hearing in the news and that kind of thing, well, one of the ones we're most familiar with anyway, is prompt injection. Prompt injection is making an AI look up sensitive data. It's injecting code via prompt. It's generally making the AI do something you don't want it to based on what you put in. The most extreme form of it would be jailbreaking or destroying guardrails, making the AI do something it was explicitly told not to do or designed not to do. Next, sensitive information disclosure. This is a large language model that is exposing sensitive data about itself or about proprietary technology. It's relatively intuitive. It's something that most of their top 10 are actually trying to induce in other models. Supply chain compromise. This is based on the fact that very few people are making their own AI engines. They're basing it on engines and modules that have been made by other people, other vendors, other companies. In doing so, you're baking in vulnerabilities which could be exploited to make things happen, like sensitive information disclosure. To tie these all together on this screen, you could use a prompt injection from a known compromise in the supply chain in a module that is inside your AI to make it put out sensitive information about your organization. Like I said, all ties together. Next three, first is data and model poisoning. Data and model poisoning is manipulating the training data that's going into one of these AIs. It can be as mild as putting in bad information so that it gives responses that would be outside of what it's supposed to do. And it can be as bad as taking a vulnerability in the model and using it to insert a backdoor when the information is fed into the training data is fed in, and activating that backdoor through a prompt. Improper output handling is that there's a failure of the output validation and or sanitization and or handling. This is often paired with prompt injection. Oftentimes the goal of prompt injection, specifically jailbreaking, would be to make some kind of improper output. Now, this can be as simple as misinformation, or it can be as complex as putting out code that would actually compromise the browser in which the AI is being interacted with, which is relatively extreme. Excessive agency is the idea that AI can make more changes or interact more with an environment it is in than it really should be doing to accomplish its task. For example, let's say that you had an AI that was set up to do looking up business records for people working inside your organization. So it had to take in transaction records or something like that. If it was given excessive permissions or excessive autonomy, it might start pulling in personal emails that reference those transactions. So that's excessive agency. Or let's say you had an MSSP chatbot. You were asking it, someone on your team was asking it about making network changes, or a user was talking about making network changes with it. And not just did it change routing, it changed access controls. Obviously, that'd be excessive agency. Next three, system prompt leakage. So system prompt leakage is another way of getting private data out. It's a way of doing sensitive information disclosure. Like I said, these are all related together. But this refers to the risk that the system prompt or the instructions can be used to steer the behavior of the model can also themselves contain sensitive information that wasn't supposed to be discovered. So you could effectively have a leak back from a specifically engineered prompt that would give back usernames, passwords, or PAM schemes, or PKI certs that were being used within the model to access other things within the model. Vector and embedding weaknesses is a way that data that is being put in, generated, stored, or retrieved is being exploited. An example of this would be, say you've got people putting resumes into an AI, and someone does that old school resume trick where they take all the keywords from your application and they put them in white text in small font at the bottom of the resume itself. So that a human looking at it is going to look at it and have no idea that that text is there. But an AI, because it's reading all the text on there, doesn't care about the font in the background or the same color, will take in that information and then will potentially reproduce the reproduce that to bias its output. Misinformation. This is one we're very familiar with from the news. It's the idea that the AI is going to put out hallucinations to overly trusting users. Now, even really accurate AIs are about 5% hallucinations, so meaning 1 in 20. And a lot of privately trained AIs can be as high as 1 out of 5 responses being a hallucination. This wouldn't be a whole lot of a problem, except that users overly rely on the information coming out of these AIs. They don't think critically and say, is that something that's possibly actually true? So misinformation can cause bad effects in humans, as well as coming out of the AI, of course. And then one that is somewhat intuitive if you stop and think about it is we're all going to CapEx and versus OpEx models. AIs oftentimes function on OpEx, and that can be exploited through something called unbound consumption. Unbound consumption is if you have a malicious user who just asks tons of prompts all at once, or asks prompts that are so complex, that all the AI's resources are going to be sucked up to try to answer this prompt. And this is as much about getting out bad data as it is something like a DOS attack. Remember, I said this is OWASP, we're concerned with confidentiality, availability, and integrity of data. If you are taking your AI and you're so deluging it with prompts that it's no longer available, then you've broken CIA unless it's a threat as OWASP is looking at it, or it's just somebody running up a bill as a way to overcharge your organization. That's unbounded consumption, meaning a user consuming things. All right, top defenses. Now, these defenses, specifically in these defenses, I'm talking about the application of AI and not how you would build out your LLM itself. When it comes to the application of AI to your environment, these are some things to look at. So first, of course, since we've talked about it so much, is filtering of the inputs and filtering of the outputs. These two things sort of go together in that they're both between the AI and the consumers. Now, consumer of the AI could be one of your employees consuming an AI that you have to help with help documents, or it could be a chatbot on your website for your end user or something like that. Consumer is just someone who is interacting with the AI. And it can also be the first time the AI interacts with itself. So the consumers put something into the AI. After it's put into the AI takes the first action on it before it really inputs into the model. That's input filtering. Then, of course, the corollary over here in output filtering is between the AI and those consumers we talked about. And it's also between the stages of the AI, because each stage of the AI outputs to the next stage of the AI, and so on and so forth. The best thing you can do for these input and output filtering for the average organization using a small language model, or you're putting in information to try to get out specific stuff for health documents, things like that. This would be a case for DLP, data loss prevention. Now, if it's stored outside your network or it's in a place that can be accessed by firewall policies, it could be firewall-based DLP. Nothing that has HIPAA information leaves this network. That would include going to like a ChatGPT website or something like that. But if it's an internal application or you have roaming data, that might be DLP on the endpoint. You want DLP located as close to the bad, as close to what you don't want to get out, as close to that confidential information as possible to stop it from getting out. So these two, this filtering for our purposes, for your applications of AI, is probably going to be data loss prevention. Next is access controls. Access controls is two-part. Number one, it's the consumers again. It's who has access to what parts of the AI. But secondly, it's also what does the AI have access to. So most AIs are going to have accesses to databases and repositories of knowledge from which to generate their answers, training data that they've worked on, that kind of thing. When we talked about the idea that they're consuming information they shouldn't consume through excessive agency or making changes, things like that, access controls are what would stop that. In the same way, it's all access controls are also going to stop someone who gets, say, the PKI search allows two parts of the AI to talk to each other through some kind of prompt leakage or something like that. Access controls, we can either stop or minimize things that are in one section getting to part of the network that we don't want them to get to, or part of the resource or part of the AI model we don't want them to get to. Think about it like identity access management or privilege access management, but included things on the machine level and including for data. This one right here, human approval, this is unfortunately not something you can get in a product. Human approval just means that there's people overlooking what the AI is doing on a relatively regular basis. This isn't a set it and forget it type thing, that there are humans that are looking in the development loop to say, have we introduced something bad? This one right here, product vetting. Product vetting, I think, is something people underestimate. Since AI technology is moving so fast, this is a legitimate case where you might get some open source stuff off GitHub that you saw an article about on Reddit or something like that, and say, man, it's a great new feature. We got to put this into our model. And that's great. That's great for advancement. Unfortunately, it's a great way to introduce vulnerabilities too, because you don't know if that GitHub, if someone's compromised that code or copied it from somewhere else and put it out with their own tweaks to make it act in an adversarial way towards your environment. So you've got to know your supply chain, know what's going into each product you're getting or each little widget you're putting on. One of the easiest way to do that is either to ask suppliers for supply chain info, or more than that, these days, you're starting to be able to consume AI modules via vendors. So like NVIDIA, you can buy different AI modules or get from them on their own programs to be used, different free AI modules that they have. And you know they're coming from a company that's been vetted, and that there's security testing being done on all these. You know they're reputable. I'm not saying you have to use somebody as big as NVIDIA, but getting someone who's a commercial startup, not just average Joe putting up code on GitHub, is a good idea. And then, of course, once you have anything in place, you need to monitor for compromised components, the same way you would monitor for vulnerabilities and anything else. And then last but not least, of course, is user education. It's just like as natural as we have phishing education and things like that these days, we need to teach humans, teach your users to spot problems that could be happening in AI. So either spot things that are in the top 10, so all the 10 things I talked about here, or to teach humans to spot AI influence, to say this is an AI influenced document. I detect this phishing email, or I detect this malicious output. I know I shouldn't click on that. I know I shouldn't ask this question. That's teaching the humans to spot the influences of AI. If all this sounds very daunting, that's because it is. Please let us at Ingram Micro help you. So we have AI professionals, we have data center professionals, we have security professionals in our respective cybersecurity center of excellences who can help you with implementing its AI applications and making sure they're implemented safely and well into your environment. A couple of email aliases on there for you. Number one, of course, being cybersecurity@ingrammicro.com for all of your cybersecurity needs. US services at ingrammicro.com for all your services needs regarding cybersecurity or any other thing you can get in Ingram Micro's catalog. And if you want to talk about AI specifically, we have an Ingram Micro line card for AI that shows all our vendors what parts of AI they do. That can be found at linecards.ingrammicro.com/AI. With that, thank you very much for talking to me today. Remember, let us help you with whatever you want. If you want to talk more of that, scan me right there is the bookings link to book time with one of our security experts. Make sure to have yourselves a great day.